Today we have Burr Stewart, and he's going to talk about steelmaking and how it can interface with our model railroads.
Thank you, Lee. I'm going to talk about what I've been up to for the last few months and really years since a group of us took a tour of the West Seattle Nucor steel plant, and I hope you enjoy it. What I'm going to cover is how I got started on this, some background on steel making, some background on the specific West Seattle Bethlehem steel plant in 1973, which is when I'm modeling, my ultimate layout plan, which is very ambitious, and then my current very stand-in setup, which is a minor version, but it shows how you can keep moving on your model railroad without finishing your dream model. And then some of the resources that are where I learned a lot about steel. So how I got into it was as a rail fan in the Seattle area, I kept noticing gondola cars full of what looked to be scrap metal. And here's three of them right here in the foreground. This is Seattle's Argo Yard, just south of downtown. And this is a picture next to the Time Oil facility in Interbay Yard. This was a train coming through, and you see there's a gondola full of scrap here and a bunch of covered gonds there. We don't know what they are as a rail fan, but I'm just saying how I got into it. And then I noticed in my model railroad, I kept purchasing scrap loads of different kinds for my own gondola cars. I bought this at the Boeing swap meet, I think. They were running around in the layout, but I wasn't sure exactly where they needed to go. And as you all may know, I have a large layout in the basement with 6 or 8 yards and a bunch of industries, and it's set up for operations. So I have train instruction cards, track warrants for train movement. I have color codes for all of the waybills so that you know where the cars are supposed to go. But the scrap metal just wasn't making any sense somehow. And I just was confused about why do I keep seeing scrap metal in these trains? So the opportunity came up to tour the West Seattle plant. And I went on this tour thinking that it would be interesting. This is a picture from outside the fence. And I found out that in the steel industry, they are very, very strict about not allowing you to take pictures or video, which I found extremely frustrating as a YouTube creator. I was not able to take any pictures inside this plant. And I saw lots and lots of gondola cars. So this answered my question of where were all these gondola cars going? They were going to West Seattle's Nucor steel mill. And the steel mill tour was absolutely life-changing. I mean, the noise and the smoke and fire and heat that comes out of this 4 megawatt electric arc furnace, which you're seeing a picture of there, is absolutely stunning. I mean, I came out understanding why people had been talking about hellfire and damnation all my life. I understood what that would be like. So I did a bunch of research to try to find out what this was. And there's some wonderful resources online, and it's a large and complicated thing, but fundamentally you take iron ore, limestone, and coal, or some heat source, and you melt it all down. The limestone is called a flux to facilitate the chemical changes, but you basically end up with liquid steel at 2,200 degrees or something like that. And in the case of the West Seattle steel mill, first of all, it's the only steel mill in this part of the country. There's one in Portland and one in Vancouver, BC, but this is the only mill. And all it's doing is taking scrap metal and melting it in an electric furnace because, of course, we have very low electricity rates here. So we don't have to worry about everything else on this diagram. But, of course, if you go back to Pittsburgh and places like that, there are plenty of blast furnaces that certainly have been in existence and all kinds of other steel facilities, which I'm not trying to model and I'm not going to talk about today. Now, once you get the liquid, you can dump it from what's called here conventional ingot teaming into little ingots that get broken down into slabs, billets, and blooms. Or you can do something called continuous casting, which is what they now have in West Seattle, where you pour the hot steel into the top and it flows down through a curved passageway, and the green here is water that's slowly cooling it down. And by the time it gets out here, it's in the shape of, in the case of West Seattle, a billet. So again, there's all sorts of things you can do for making all kinds of steel, whether it's tin for your tin cans or rails for your railroad track down at the bottom. But what's happening in West Seattle is simply they have a continuous caster, they melt down the scrap, it comes out as billets, they store the billets until they need them, and then they roll the billets into rebar or small angle iron. They don't do anything large there anymore. And again, you can study these diagrams later after I post this presentation on the 40PNR YouTube channel. But it's fascinating, all the different things that can go on. Fortunately for us, it's not that complicated. Now, this is an aerial photograph of the original Bethlehem steel when they bought it from Pacific Steelworks. This is what was there. And I think this photograph is around 1930s. And the more I look at this, the more astounded I am, because they had what's called an open hearth furnace, where they were taking coal and ore and scrap, and they were making liquid steel, and then they were turning out the reinforcing steel department would be the rebar mill, and they had mills for other shapes of steel. They had a plate mill where they were making steel plates. So they were doing a huge amount of different types of steel work here in the 1930s. And you can see over here on the right, there's an enormous scrap yard where they were working with the inputs that they were getting. And this open hearth furnace was eventually replaced by an electric arc furnace. And what they did was to take half of the scrap area and build this whole new furnace there. This is a picture of the furnace, which the furnace itself was added in 1958, and then they added the low temperature baghouse in 1973, which is this very large thing. And anytime you drive across the West Seattle freeway, which is right here, you see that enormous duct that takes the low temperature air out of the top of the ceiling from every time that big fiery blast happens, and they go through a big baghouse. And the nice thing for modeling this is that the dust from the baghouse gets reprocessed at a factory in Montana. So it goes out by railroad car to Montana in covered hoppers. So this is this waste product of the steel making is one of the sources of traffic for modeling a steel mill. Now, later, after 73, they added a high temperature baghouse. I'm trying to spare you too much of this minutia, but it's kind of interesting that this is called the LTBH, which is the low temperature baghouse. And there's also over on the left here, at the current day, there's an HTBH, which is a high temperature baghouse. And I'm not going to be modeling that because I'm modeling 1973. But if you wanted to do a newer model, you want that second one.
Can you explain the word baghouse? Why is it called
Oh,
that?
sure. Well, a baghouse is a big box with a bunch of vacuum cleaner bags in it that are made of some kind of fabric, and they collect the dust that's in the air. It's essentially an air pollution control device, but in the case of steel, the dust contains iron. And so it's very cost effective to ship the dust to a factory specifically made to re-extract the iron from the dust and then send it back to the plant as iron. What it looks like now, this is an aerial photo from Google Earth. There's an electric arc furnace over on this side. The scrap charging area, part of what I'm doing is giving you some steel making jargon. So charging is the word for loading the scrap into the furnace. It's lined with refractory so that it can go up to very high temperatures for the melted steel. And this is the original scrap sorting area, and they put a big roof over it because, of course, it rains, and they want to keep the scrap dry because if you put water in that bucket, it's going to make a lot of steam and and mess. Then there's a trestle where the lime and additives go up a little trestle so they can be dumped into the charging buckets. The charging buckets are the things that carry the scrap over to the furnace itself. Then out of the continuous caster, which is in this little building here, the billets come, and they get stored in a big yard there. And you can sometimes see this when you drive by on the freeway. You can look down and see the piles of steel billets. They're about 4 inches square and about, I don't know, I meant to find out how long, maybe 40 feet long or something like that. Yeah, they might, I guess I don't know how long they are. And then this is the rolling mill for the rebar and the angles that they have. What they do is they heat up the billet to a high enough temperature that it can be rolled. And then they go through a series of, I can't remember exactly, but something like 14 rollers that slowly make it thinner and thinner and thinner. And over on this side, you have a piece of rebar coming out at a very high speed and hitting a wall at the end here. And then they have a crane and they load the rebar into gondola cars over here. And if they have a lot of extra rebar, they take it over here and store it in the shipping department, which is on the side here. And I'll show you another drawing in a second, but right around 1973, they also did a big track relaying project where you can't see it too well here, but there's a lot of railroad track. In my next picture, you'll see it, all leading into these facilities. It's all very much rail served. And there's a little tiny engine house here, which cracked me up, and I wanted my model to include that because there is an in-plant engine, 2 of them actually, that do switching all day long, moving all this stuff around in rail cars. And the plant has its own yard, which I didn't bring a picture of, but it's up here to the north. They have their own plant yard, and it's right next to the Burlington Northern main yard, so that the BN can shove them the cars that are built for the mill, and then the mill switcher can handle all of the switching in here. The last thing I wanted to point out is all this switching in all these buildings and everything else is handled with a very tiny little yard lead because, of course, this steel mill is in the middle of a residential area, and they just don't have room to expand. So you can see how they kind of twisted the lead right into the corner. And it reminds me of things I've done on my model railroad many times where I just wanted to get the maximum length out of a piece of track, and I just bent it into a corner. Have you ever done that? So this is another view of just one side of the plant that gives you an illustration of how much fun this could be as a model railroading subject. This track goes all the way over here to the shipping department where they store the excess rebar until the market demands it. So they have to pull the rebar out here, then they have to switch it over here, send it all the way back underneath the baghouse and over to their mill yard, which is here, and give it to the Burlington Northern. That's just one move I'm describing. Now, if the limestone comes in for the flux, they get that from the Burlington Northern, they take it out of their yard, the switcher brings it all the way around here. You see where I'm going with this? Then they have to shove it up this dirt hill, and then there's a trestle here, which I don't have a picture of because they wouldn't let us take any pictures, which makes me really mad. But anyway, they shove that up into a higher store here. Now, I mentioned the low temperature and high temperature baghouse. So this is where the big vent goes into the low temperature baghouse. And then later they built a high temperature baghouse to take the hot gas right out of next to the furnace. This is, of course, an insulated pipe because it's very, very high temperature. You see this? This is a typical high temperature roof vent type of thing. And of course, this creates dust as well. This shows, again, the roof over the scrap sorting area. And the engine house is down here. This little tiny thing, this is where they work on the engine, maintain it. So, of course, the engine would pull out of there, come out here, and get to work. I also love, they have a storage yard here that's, full of cars, empty gons. This is probably covered hoppers with limestone in them. Here's some loaded scrap gons. See what I mean? Isn't this kind of exciting? All this model railroading in one little spot? I corresponded with the tour guide that we had, and he actually sent me some drawings from the company. This was the project they did, I think it's around my modeling time, where they redid all this track. And as I showed you on the earlier slide, they modified it after this drawing was done because that lead track, as you saw, curves over into the corner. So some brilliant engineer at the time said, we could get an extra half a car length here if we just bent this over. Isn't this funny? I love it. Anyway, this is a picture of the original firing of the electric arc furnace at the West Seattle plant. And it gives you an idea of the size of it and the complications of it. Now, Walthers makes a kit for an electric arc furnace, which I don't have to tell you I have purchased. And I plan to use this when I make my big model. So how do I model this when I've already got my layout built? So I realized we had Lego Town and a West Seattle shelf that was kind of underneath the Ballard Branch, and I could just expand that and make room for a larger model. This is my color scheme, and I just was going to show you that I have a lower deck where we have Harbor Island in West Seattle, and I could add onto that West Seattle lower deck, and it would be a sit-down job. So this is a couple of pictures I just took yesterday, and of course you can see that my stand-in steel mill is already in place, but this is the lower deck. See Lego Town here on the right. Lower deck was in place. And then what I'm talking about is I could put the steel mill model in a space here that's about 4 by 10 or something like that. And it would have access to the West Seattle yard, which is back here, through the bottom of the layout there. So it's a little crazy, but I could do it. So, of course, I immediately started making drawings. And this is my first attempt at a model of the steel mill in my confined space. And as you know, model railroaders are always cramming things into very confined spaces. Now, in this case, you can see from the grid here, it's about 4 feet this way and about 10 or 12 feet this way. And so just to talk you through this is the West Seattle yard, which is about 5 tracks. It's an S-shaped yard that goes around to the area that I've already built. Coming off of the West Seattle BN yard, BNSF now, is a single track that goes to the mill, and that's because they have something called a radioactivity detector on there, and everything that goes into the mill has to be tested for radiation, because the last thing you ever want to do is have radioactive material in your steel, because that's totally not sellable. So they do this radiation detector, and then that gets the cars into the plant. And then they have the mill yard where the plant switcher can sort the cars and figure out what to do. And of course, there's also obviously a scale where they weigh everything going in and out so they can build properly. So then over here, and again, this is just my first drawing. I just wanted to show you how to think about what you just saw. Here we have the low temperature bag house and the electric arc furnace. The continuous caster would be over here. But there's no point in modeling that, and they put that in around my era, so I could have ingots of steel coming out and then going into what's called a stripper, which is where they would remove after it cooled down, they would remove the metal from the ingot mold and then go on making the steel in the rolling mill. So all this could theoretically fit in this small area. I'd have at least one track for scrap, and I could have that little incline for lime. And also I could have a track for additives. And of course, the gonds coming out of the rolling mill would have rebar in them. And there could be an engine facility right there. And I could even cram in at an angle the shipping building. And I could have gonds full of rebar coming out of the shipping building as well as rolling mill. So this is what you call, doodling. It's much easier to make a track plan with a pencil than it is to use actual software, which would constrain you to using realistically buildable turnouts. Because as you see, I've got a big problem here. In the space of about 2 feet, I have about 6 turnouts or something. Now, this is not buildable. It looks great on paper, but I have a lot of work to do on this track plan before it makes sense. The good news is that I don't have this space buildable yet because there's no bench work or anything else. So this is where we get into the balance between physical and operating realism. So when you're making a model railroad, visual realism to its ultimate would be a museum diorama, and something like a time saver switching puzzle would be realistic operations, although you could debate that. But the sweet spot is somewhere between, where you're trying to get some of the look of the prototype and some of the fun of the operations of the railroad. So anyway, I ended up deciding to do something on the bench work that I already have as an interim step, a stand-in. Now, some of the other advantages of deciding to model the steel mill was I could buy gondola cars like crazy. So ever since we went on the tour, I started acquiring gondola cars, and there are a lot of great choices. And I haven't opened any of these boxes yet. So this is the future fleet of gondola cars that will support this plant. And of course, I couldn't resist buying a couple Walthers slag cars for the slag. And there's a little Bethlehem steel switch engine that will be great for switching the plant. And there are several companies that make specialized steel mill equipment, such as these ingot buggies, which is a Rick's Products kit. And there's a State Tool and Die company that makes a variety of kits as well. And so steel mill modeling is the thing you can do. Now, Walt Apple, who some of you may know, has a beautiful model railroad in Linwood, was getting rid of some of his excess stuff and said, "You want a steel mill building?" And I said, "Yeah, of course I do." So he gave me the steel mill building, and you can see it has an opening on the left where I could have scrap coming in. And then I thought, I can hide the shipping department behind this. And I fussed for a long time trying to figure out how to just get this in the corners. It's kind of too big a building. And this really set me back, having this model, even though it was a gift. It forced me to dither about what was the best way to build it. And because I couldn't figure out how to cut the sides. They were made of Lexan plastic, 1/8 inch, which is very hard to work with. And you can see here, I was picking up little pieces of rebar just to remind myself what this was all about. And at some point, I abandoned this building. I decided that it was too big for what I was trying to do in this corner as a stand-in steel mill. But before I did that, I did start operations. As you see, I put that switch in with the switch machine, and we did start shipping gondolas full of scrap metal and additives for the plant. We did start shipping them and billing them to the West Seattle mill. You can see that little switch engine over there in the corner. So at some point, I realized I was going to abandon that building and just do it right. Oh, and of course, the other thing that happened was my friend Dave Angers said, "Don't do any track until you get the backdrop up." So that set me back a couple of years because I had to take some pictures of the skyline and then get that printed up on some kind of plastic, which took a while. And the whole time I was working on the backdrop, I wasn't doing anything else because he correctly said it's a real pain to work on the foreground first and then put up the backdrop. Anyway, the main point of this is I got the backdrop up eventually and started track planning in earnest. I didn't use a computer program. I just had a bunch of switches. And you've read about people you can download paper templates. You don't even have to buy the switches. But you do have to correctly lay out what you're going to do with the track. And so I did that. Also, Dave said, don't put the track down until you've painted it. So I went through, and I was hot to trot, but he kept saying all these things that delayed me. But it was really good that he did, because it turned out, it didn't take very long. Once we got the track laid out, it didn't take very long to tape it all to a big piece of cardboard, take it outside and spray paint it. That meant that right away, as soon as I actually laid it, it looked great. So this is the gluing down the track part of the project. Those are just weights holding down. The way I do track is I use push pins to hold it where I want it, and I drip liquid latex on it a little bit, enough to tack it down. The liquid latex then dries, and it's not water soluble, so then I can come over with ballast and Elmer's glue later, and I don't have to worry about the track moving around underneath me, which you would if you used a water-based glue. A lot of people like to use caulk for gluing down track because it's faster, and I just haven't gotten into doing that, but it's the same idea. You have a glue that is not water soluble once it dries. Anyway, I got a kick out of this picture because the weights kind of look like buildings that are imitating the backdrop. And then I realized that I had an old Sudam metal engine house kit that I had bought at a swap meet many years ago. I was using it for a steel company in Ballard on my Ballard branch. And I realized it would fit perfectly in this spot that I had been so confused about with the previous building. And the real thing, just talking about layout design, the real thing is that you got to try to think about every aspect of this. So the great thing about this stand-in building is that you can see the backdrop behind it. Whereas that huge model that Walt had given me would have completely blocked this backdrop and wouldn't have made sense. It didn't fit in the amount of space. So this is my stand-in. And of course, it doesn't really look like a steel mill, but it looks more like a steel mill than some things I could put here. I could put a foam core mock-up or something, but this looks better than a foam core mock-up, so I'm going with it for now. This is the same area without the building, and I'll show you what we're using these tracks for now shortly. And this is just to say I was joking about model railroaders using every possible space available. I realized that if I made a very low cut in the backdrop, I could shove gondola cars all the way to the wall because this is a curved backdrop. So this gives me an extra couple of gondola car storage length than I otherwise wouldn't have if I hadn't made this. But I made the low cut because I have no intention of anything else getting in here except gondola cars. This is the shipping department tracks back here. Of course, the other thing that's involved is making car card box labels and stuff. So this was my process of getting the operating part of the new layout working. I'll show you that in a minute. And we started operating immediately. As soon as this track was in place and I cleaned off the top of the rails, we spotted an additive here. No, I'm sorry, not an additive. This is a car for picking up the baghouse dust. And this car is billed to be sent back to Montana. I'm not even going to tell you about that car. So now I'm going to just show you what these different tracks are for, imitating the steel mill that I showed you earlier. Scrap gons go in here where they get loaded in. Billets coming out of the furnace and slag coming out are on this track. The lime and additives in are here, and the baghouse dust is coming out, and I'm using the same track for both, which is fine. It'll be a switching challenge. And then, as I said, the rebar is coming out. The shipping department is back here in theory. Now, moving a little farther away from the plant, but still related, I have a hillside here, I just happen to have it, that might make a great slag dump. So we could pull slag out of the steel mill and move it over here and dump it, which seems like you would have that in a steel mill. And the other thing I found out from the tour guide was in West Seattle, south of this area, I can't remember now if he said it was 8 miles away or something like that, they have a scrap sorting facility. So the gondola cars don't go straight to the steel mill. They go to this sorting facility because there's something like 21 different grades of scrap metal. And so this is a whole can of worms, a rabbit hole you could go down, just figuring out the different types of scrap and which ones get involved with which type of steel. And Fortunately, I'm not going to talk about that more than to say that I'm planning to put some piles of scrap here with a crane or two, and we'll be able to bring cars in to the scrap sorting facility and then take the cars loaded with the correct type of scrap into the mill. And that's a whole hobby we could have. And this is just to show that, well, it's a welcome sit-down job because it's at a low level on the layout. But also it has this interesting double scrap move, and I've made some waybills up. Sorry, they're a little blurry, but you can see this waybill here for a gondola says, come from Vancouver, BC, a Canadian car, that would be CN or CP or PGE or something like that. Canadian car would come in from Vancouver with some scrap metal. But it would go to the scrap sorting facility that I just showed you away from the mill. And then on the second turn of the waybill, it would actually go to the scrap bin track at the steel mill, loaded with scrap from the sorting facility. Then it could go somewhere else. In this case, it's an on-layout scrap dealer empty. And then it could go with scrap back to Vancouver where it started and then come back through the cycle. But that's a double scrap move. Actually, it's more than double, but it is a double scrap move to have it go to the vicinity of the plant and then go into the plant. So this is the left side of the area. This is the new West Seattle yard with the backdrop. And I built a runaround track so that we can take a train into West Seattle, run around it, and then sort it in the yard. And I also remembered hearing from Ray Wheeler that they used to have cement covered hoppers would go into the Ideal Cement plant, which is very close by in West Seattle there. So I thought I would throw a couple of tracks in there and make a very condensed version of a cement plant there for more interest. And at the last minute, I thought I should have a loco pocket to park engines and cabooses from the train that comes down to West Seattle. Now, this lead track here, well, the lead track's over here, but this track over here will end up being the track taking all of the gondolas over to the West Seattle mill when I get the big model done, but that's a whole nother story. So here's the schematic diagram of the whole shelf that I just showed you in the form of a SPINS handout. And SPINS is the same as CLIC for you Santa Fe people. It stands for, originally Southern Pacific Industrial Numbering System, but BN changed it to the Shippers Perpetual Industrial Numbering System. And they had these employee maps that the crew would carry around with them, knowing which number track was where. And of course, this was all part of the early computerization of operations. And since I'm modeling 1973, I'm trying to imitate that. This is the list of all of the spots that are available on each of these tracks. And this is all taken from prototype information, what was there, with one exception, which is, you'll notice here, I have Northwest Shortline. And that's, of course, a model building company that used to be located in West Seattle, right near the tracks. And they didn't ship or receive anything by rail because we're talking about very small, very valuable boxes of brass engines. But I thought it would be fun to ship something in and out of Northwest Shortline just as a memory of the fact that they were a Seattle company. So this is 18 turnouts with 28 industry spots on a shelf that's about 13 feet long and 18 or fewer inches wide. This could be a whole layout. I have no idea why I built this. I already have a layout. But now we can bring trains to West Seattle and we can run around them, sort out the cars, and support Bethlehem Steel.
I'm looking for the engine house on that track plan.
That was for the big ultimate model. This is just the stand-in model that I've been showing you. This little thing here is just what I could do with 5 tracks to model Bethlehem Steel. The big plan that I showed you before with the engine house, that's going to be a much bigger model and we'll have room for the engine house there. And this may be part of why I put in the 619 here, the BN, because I have that engine stored there in the loco pocket. But that's about all I can do for the moment. So if you're interested in steel, there are a couple books to know about. Dean Freytag was the sort of the father of modeling steelmaking, and he wrote a couple of really good books on this. And this was published by Walthers, the History Making of Steel. It's a very, very good book, and I recommend it. Actually, I recommend you stay away from all this because it's just a rabbit hole distracting you from what you're really trying to do. But that's another story. And then Phil Burnside is a guy who runs the Steel Mill Modelers Special Interest Group. He's a 3D printing guy, and he's done a lot of really interesting modeling that he talks about here. And I didn't mention the word mini mill, but it used to be that steel mills were integrated, so they did everything. They built the pig iron, they turned it into steel, they rolled it. They did all the stuff in one big, huge plant back east. But then over time, these mini mills came up, and the West Seattle mill is a great example where all it's doing is melting scrap and making rebar. So it's not a full-on steel mill, it's just kind of a minor thing. And the Steel Mill Modelers Journal is published at once a quarter by the organization. And it's a fun group to join. I don't know how many members they have, but they're all over the world. And they have Zoom meetings once in a while, which are a lot of fun. And they recently, as you can see here, this is the summer edition of the magazine. introduced the fact that there's an organization called the Society for Industrial Archaeology, which is much larger than the model railroading community, and they've just established an Iron and Steel Heritage Forum, which is essentially like a SIG, where they're going to be discussing this and sharing photos and drawings and everything else. So this is another great way to get more research. And the Industrial Archives and Library has a lot of great photos of this type of thing, which I haven't had too much time to look at, but I've been too busy making my model of the West Seattle Steel Mill, which is what this has all been about. So my final thoughts or conclusions about this, lessons learned, is try to not be like me and always be curious about why and how everything happens, because you end up spending a bunch of time on a whole new project you didn't even know you wanted to do. If you had just kept your mouth shut, you wouldn't have even learned about it. I'm just kidding. But don't worry about track planning software. I hear a lot of people agonizing about what software to use, and I would just say start putting track down on a surface and see what fits and play with it. And don't be overly constrained by gifts from people. I showed you the steel mill model that I got, but I ended up not using it because it just didn't quite work in the situation I had there. Put the backdrop up before you lay track. This, of course, comes from Dave Enger. And paint the track before you glue it down, which also was his idea. Operate it as soon as possible to uncover flaws, and I did that. I just can't help myself to try to get trains running as soon as possible. And do what fits and is fun to operate over copying the prototype. So what I have is essentially a model railroader's approximation of the West Seattle Steel Mill. It's not particularly accurate yet. I'll try to make it better over time on the new surface that I developed. But the main thing is to keep going. And the best way to do that is to use temporary stand-ins. And a lot of you have done this in your presentations where you've shown you had a foam core building or something just so you could get trains running and enjoy model railroading. So that's my presentation. Stay tuned for more steel mill operating fun. And be sure to check out my YouTube channel because I have lots of YouTubes about the process of this. And I am going to publish one where I show the actual steps of track laying and that I just went through in a video form. So I guess with that, I will stop sharing and we can have Q&A.
Thank you, Burr, very much for excellent presentation as usual. And before I open it up to questions, I had just a couple of comments and observations, which maybe people have seen. You've stated some of these, but it's so interesting how, we're all kind of on a journey of lifelong learning. So you talked about these rabbit holes, but that's the fun of the hobby, is going down some rabbit holes and learning some things that you didn't know before. And then another thing that I found fascinating was what I would call consistent crudeness. You have figured out how to put enough of the steel mill operation onto your layout that it will fit in the space that you have and yet capture much of what is done by that industry. So I think that's just genius, in terms of what you've done in that one corner of your room. It's fantastic. And then I would add, well, I'm a structural engineer by practice, training, done this for many years. So I've used a lot of steel. And so one thing just to reinforce, and I think the books at the end help sort this out, in your consistent crudeness of this one rabbit hole operation, it's really the ultimate recycling event where you're taking effectively steel that's already been made and recycling it into another usable product, which is primarily reinforcing steel, rebar. And that helped keep everything small. What people may or may not be aware of is, you see steel making in the blast furnace. The blast furnace makes pig iron. And that's the beginning of making steel from natural resources like iron ore, limestone, coal. But the product has way too much carbon in it, and so it's brittle and not very useful structurally for anything. We use cast iron for many years, but it's a brittle material, breaks like a piece of chalk. To turn it into steel, you have to then get rid of that excess carbon and lower the carbon and use basic oxygen, various processes to do that, which are all the spectacular Hellfire and Damnation photos that you had in the beginning. And so it's a huge operation. Like you said, these integrated things back east that we had for many, many years, but that's making steel from natural resources. And I think it's genius that you're making steel from steel as a recycling event in the corner of your train room. So just a few comments that maybe help people. You don't have to have the blast furnaces to have a cool steel operation on your model railroad is the point. So with that, I'll open the floor for questions from the folks that are on the call here today.
I just want to thank Burr for the excellent presentation. I really loved it and learned a lot and was inspired. On my own future layout in progress, the big industry will be a cement plant. So I can relate the steel mill to the cement plant. And I asked about the bagging house because on the cement plant, the bag house is where they put the cement powder into cloth bags and shipped them out in boxcars before covered hoppers were very common. So thank you for that.
Burr, it was excellent presentation, and I admire how you're able to stuff an awful lot of activity into. There are a lot of other things that would be needed or appropriate for your steel plant. Other supplies that would be shipped into the plant, either on flat cars or in box cars, other than scrap steel. I'm thinking in terms of other chemicals, lubricants, and so on, and other machinery that would be shipped in to make the plant continue to work.
Yes. For example, there's a whole industry that makes those carbon electrodes that go down into the furnace. And those are big carbon electrodes that come in a big, I've seen 3D printed models of those electrodes designed as a flat car load. So and I think they go through them, I don't know, once every week or two, they have to replace them because they really, get worn out from all that high electricity.
They're consumable.
Yeah, they're consumable. They're consumable electrodes. Right. So that's just one example. And of course, there's a variety of additives that they receive. And of course, today, most of that is done on trucks. But in 1973, I'm going to take a lot of liberties about bringing in different types of machinery and supplies. And refractory brick, that's another whole big industry. So the bricks that line the vat, they come in boxcars. And if I had more room, I would model, we'll see what happens, but I would have a place where you can unload these supplies like the bricks and the electrodes and all that. If you go on the plant tour, you can see they have quite a bit of land dedicated to the storage of their supplies that they need to keep the whole thing running. A good point, Ross. Thanks.
And in 1973, major categories of input for reinforcing steel, in addition to scrap or in case new billet steel, were the categories of rail. They used a lot of rail to make rebar in those days, and axle, railroad axles, which surprisingly fatigue because every time you turn, you get a cycle on the axle. And so they would eventually not be usable and were recycled into reinforcing bars.
You just made my day. That is great. So I can have a pile of old axle. I got so many axles with wheels on them. I'm just going to make a big pile of them right in that scrap sorting area, spray paint them all rust color, and we're good.
That's right.
Excellent. Excellent. John was mentioning cement. We went on a tour of the cement plant in Seattle not long ago, some of us. Ash Grove. One of the things that astounded me was that the furnace at the cement plant is so hot that one of the things they use for fuel is used tires, steel belted tires. And it's so hot that it melts the steel and burns all the rubber in the tires. So they have a conveyor there where they just bring the tires right into the cement. What do they call it? Retort?
Yeah.
It's a vertical furnace.
Right. And the
material is coming down from the top. And they just throw every minute or something, they throw another tire in there, and that's part of the fuel that they're using.
It burns so hot that it's
Yeah.
not like a smoky tire fire.
Right.
It
Right.
burns surprisingly cleanly, so
Right.
they get green credit for it.
Right. Right. We digress.
Yeah,
Hey,
you're probably
Burr,
not going to use tires for your steel operation in West
No.
Seattle.
No.
Hey,
But-
Burr, I'm a little confused about the small steel mill you've already built versus you have a vision of a larger one.
Yeah, I did.
How is that going to work? Is one going to replace the other or what?
Yes, that's a really good point that I kind of glossed over. I really wanted the steel mill cars coming in and out of the plant, so I put that 5-track complex in the corner. But what was actually there on the prototype was Wyckoff Industries, which was a huge creosote tie staining operation. What I'm planning to do once I get the larger space available for the drawing that I showed you, that had the engine house and everything. Once I get that going, I plan to repurpose the area where the steel mill is currently for the Wyckoff plant. And then we'll be able to bring untreated ties down there and treated ties out. And we'll have tank cars bringing creosote in and so forth. But that's for a future year.
Where does the big steel plant go then?
It goes underneath the Ballard branch.
So it doesn't replace the existing
It doesn't
one.
replace the existing. It's in a new location, not too far away.
Okay.
And it's still a sit-down job.
Basically
Yeah.
over your left shoulder, isn't it, Burr?
Yeah. Oh, that's a good point. That's a
Yeah.
good point. It's right down in here is where it is on the layout. That's where it is in the front. Where the steel mill is currently is down. It's hard to point. It's down in here on the other side, down at that level. So it'll all be at the same level. That'll be we can schedule that for one of these talks in 2028. We got to get past the NMRA National Convention in 2027, which somebody should mention that while we have everybody on, that August 15 through 20, I believe it is.
Yeah.
2027, we're hosting the NMRA's National Convention here.
Yeah,
So,
in Tacoma, in the
Tacoma,
Greater
yeah.
Tacoma Convention Center, which
So
is
this is the
very
time
nice
to,
facility.
to make your plans and plan to be here and not traveling somewhere else.
Hopefully,
Another
we could
question.
have Burr give a clinic on.
Oh yeah,
steel
I can.
modeling.
I'll give a clinic on modeling West Seattle steel mill at that convention. That's a good idea.
And how to build a model railroad and then put a house on top of it.
Right. Yeah. Or maybe it would be called, "Why build one model railroad when you can build 6 in the same space?"
Burr and I have similar tendencies that we can continue to work through our head and stuff more model railroad into the same space we started with until finally it's probably obvious to no one but ourselves
Yeah.
how the thing
I-
operates.
I completely glossed over the fact that Lego Town is going to become Harbor Island. And of course, Harbor Island has the Fisher Flour Mill, which is a very large flour mill with a lot of covered hoppers going in and out. And we need to model that as well. That'll be for 2031, I guess.
Yeah.
First, we have to get the steel mill done.
And Burr, I noticed that your backdrop seemed to be era appropriate. I saw the Safeco building, which also known as the box of Space Needle, came in. It's a black bank building off to the right, and in your backdrop, and it was built in '69, so it's perfect
Yeah, that's
timing.
good. Thanks for bringing that up. I meant to mention that Mike Slees is the one who printed that backdrop. He has a print shop in Tacoma, and he knows a lot about model railroad backdrops, and he did a beautiful job. It's printed on 3mm styrene, so it just curves right in. In fact, the backdrop is not even glued down to any attached to anything. It's just sitting there waiting for me to decide how to attach it to the layout, because the 3mm styrene is heavy enough that it sits there right in the corner. It's very nice. Well, I have it pinned. That's true, a little bit. It's not particularly era appropriate because it does have some of the high-rise buildings that have been built more recently. But the good thing is
That's okay.
that people immediately recognize it and they feel that they're in West Seattle, even though it didn't quite look like that in 73.
Burr, was access to that plant area across that NP bascule bridge over the Duwamish?
Yes, I have a model of that bridge. You know, I don't know if you all know that the Walther's single track bascule bridge is modeled after that NP bridge that goes across from Harbor Island to West Seattle. That is the prototype for the Walther's model, which is being used all over the country, and nobody knows that. Unfortunately, the space that I have, when I put that model in there, it just overwhelms the space because it's so big. So I'm not sure if I'll ever go down that particular path or not. It would be really fun to have that bascule bridge that you would have to put down in order to get to the West Seattle, but we'll see. We'll see. I need a condensed version of that bridge that's about 70% of the size of the real bridge.
Or just the operating procedure of, okay, you come out of the mill,
Yeah.
how do you get across that bridge? You know, they've
Yeah.
got to put it down so there's
Yeah.
some control there. That
Yeah,
would
that's
be,
right.
like, to loop back to what John was saying, if somebody knew how all that worked, it
Yeah.
could be interesting in the whole planning of your day as
Definitely.
a switch crew.
But, you know, I used to work at SeaTac Airport, and I drive by the waterfront yard every day on my way to work on the viaduct. And I would see these gondola cars, these strings of old GN and NP gondola cars just sitting there full of scrap, wondering what is going on. And I didn't know anything about the plant. So having all this done now, it makes me very happy. Now I know.
Well, there any other questions or comments that the group has this morning? If not, I will say let's give Burr a big round of applause, or quietly here, for putting this together. And we really appreciate all the effort that Burr put into this. And I, for one, can't wait to operate the new steel mill over at Burr's place.